Okay, Introduction to Trigonometric Equations, Part 1. So let's do a little startup on solving equations algebraically. So here I'm going to add 2x to both sides. That's 0 on the right side. That's 5x minus 7 equals 8. Add 7 to both sides. And that's 5x equals 15. I'm going to divide both sides by 5. And I get x equals 3. Okay, so the whole goal here is to isolate x. Let's see a quadratic example. So I'm going to subtract 42 from both sides, 3x squared plus 11x minus 42 equals 0. For 30-1, I'm going to challenge you to factor this by inspection. I know this is where a is greater than 1, right? So I know the first term has to be 3x and x. And then how do I get a minus 42? Sorry, how do I get it to add to 11 in the middle, 11x? So if I go plus 6 and minus 7, that's 18. Plus 18 minus 7 is plus 11, so that works. This is a quadratic, so I'm going to set each factor equal to 0. That's x equals 7/3. And this one, x equals negative 6. This one, we had to isolate x, and we had to use some factoring. Okay, so when we solve trigonometric equations, so solving first-degree trigonometric equations, so we need to do think about the same thing. So isolating x and then factor where necessary if you need to. So for these first two, example 1, solving first-degree trig equations. Let's look at these instructions. So treat sine of theta as a variable and isolate it on one side of the equation. Use the cast rule to determine which quadrant. Okay, so this is very important. And determine the reference angle by using the inverse of the sine, inverse of this cosine, inverse of the tangent. But you must use the absolute value. Pay attention whether you're in degree mode or radian mode. And then determine all angles which satisfy the specified domain in each quadrant. So remember, you might need to find coterminal angles. Okay. Let's take a look at this. 3 sine of theta plus 1 equals sine of theta plus 2. I'm going to subtract sine of theta from both sides. That is 2 sine of theta plus 1 equals 2. Let me subtract 1 from both sides. So I have 2 sine of theta equals 1. Divide both sides by 2. I have sine of theta equals 1/2. And then I need to take the inverse sine. So I need to find the reference angle. So inverse sine. So the reference angle equals the inverse sine of the absolute value of the ratio 1/2. And we need to take a look at this part right here. Let me calculate my reference angle first. That is pi over 6. From this, I can gather that the sine ratio, sine of theta, is positive. So using the cast rule, I know that's quadrant 1 and quadrant 2. Okay, so remember cast rule, C-A-S-T, tells you which ratios are positive in which quadrant. So I set up my solution in terms of which quadrant they appear in. So quadrant 1, reference angle equals pi over 6. Well, in quadrant 1, we know that angle in standard position equals the reference angle equals pi over 6. In quadrant 2, I have my reference angle equal to pi over 6. Well, in quadrant 2, I know my angle in standard position is pi minus the reference angle, and that equals pi minus pi over 6, the reference angle, and that's 5 pi over 6. Okay, quadrant 1, quadrant 2. Within the domain of 2 pi, do I have any more coterminal angles? If I do another full rotation here plus 2 pi, well, that's outside of my domain, so I'm not going to get another solution there. If I add 2 pi to this, that's going to be outside of this domain again, so I always have to check for coterminal angles. So I don't have any coterminal angles, so my solutions theta equals pi over 6 and 5 pi over 6, and I'm within my domain there. Okay, before I move on, I need to point this out that we have to do this analysis. So this analysis where we go to quadrant 1, quadrant 2, we see where is the sine ratio valid in which quadrant, and then we have to manually do this calculation, because here's the problem. I'm going to show you just a little segue here. I'm going to show you, let me just have another page here. If I take that part of the equation, so remember we had this part, sine of theta equals 1/2. Do this on your calculator. Reference angle equals inverse sine of 1/2. If you just rely on your calculator, remember your calculator will give you part of the solution. If you do, so radian mode, make sure you're in radian mode. If you do the inverse sine of 1/2, I get 0.5235987756, which is pi over 6, folks. Okay, so if I do pi divided by 6, that's the value. If this is by calculator. If you just rely on the calculator and you stop and say, oh, and you happen to know that's pi over 6, and you say you're done, well, this is only part of the solution. That's why you have to do the solution in quadrant 1, right? And you have to draw it out. And you have to do the solution in quadrant 2. This is the solution in quadrant 2. When you do it on your calculator, this is a quadrant 1 solution. The calculator doesn't show you the quadrant 2 solution. You have to reason this out by hand, okay? So that's why we do this by hand, because your calculator doesn't show you all the solutions. All right, back to our problem. Okay, letter B. Let's follow the same steps. So I have square root of 3 secant of x plus 2 equals 0. Within the domain negative 360 to positive 360. So square root of 3 times the secant of x equals negative 2. So let me subtract 2 from both sides. I'm going to divide both sides by square root of 3. So I have negative 2 over square root of 3. Okay, so the secant, our calculator won't return inverse secant values. Just doesn't. In most calculators, a lot of calculators don't have it. So I need to think in terms of the primary trig ratio. So be careful when I do this. So I know the secant of x is the same as cosine of x. That's one of our trig identities. Okay. And that equals, don't flip over negative 2 over square root of 3. I'm only switching this side. I'm applying the identity to the left side. The right side stays the same. So now, if I take the reciprocal of both sides, or if I raise both sides to -1 exponent, I get cosine of x over 1 equals square root of 3 over -2. Or if I adjust the placement of the negative sign, I want to put it out in front. So it's negative square root of 3 over 2. And then I can just clean this up. I don't need to write over 1. Okay, so that's how I get, and then let me just rewrite this. That's how I get cosine of x equals negative square root of 3 over 2. For my reference angle, XR, I need to take the inverse cosine of the absolute value of negative square root of 3 over 2. And knowing our exact values, this is in degrees, folks, so make sure your calculator is in degrees. My reference angle is 30 degrees. And from here, cosine of x is less than 0. So my solutions will appear in quadrant 2 and quadrant 3. So I need to check those two quadrants. Okay, quadrant 2. My reference angle of quadrant 2 my reference angle of 30 degrees. So in quadrant 2, what is my angle? So angle in standard position in quadrant 2 is equal to 180 degrees minus my reference angle. So my angle in standard position, let me use x's here. Sorry, folks. Just use the correct variable. I have x sub r equals 30 degrees. So my angle in standard position equals 180 degrees minus the reference angle. So in this case, 180 degrees minus 30 degrees. My angle in standard position in quadrant 2 is 150 degrees. Okay, and then quadrant 3, quadrant 3, I am down here. I have, come on. That's a reference angle of 30 degrees. And I know in quadrant 3, angle in standard position is 180 degrees plus 30 degrees. So my angle in standard position, 180 degrees plus my reference angle. So that's 180 degrees plus 30 degrees. Angle in standard position is 210 degrees. Okay, I have one solution. I have another one, but pay close attention to my domain, which is negative 360 degrees and positive 360 degrees. I have x equals 150 degrees. Well, if I subtract 360 degrees, I get x equals negative 210 degrees. So that's another solution. Okay. I also have x equals 210 degrees positive. If I subtract 360 degrees from that, what do I get? I get x equals negative 150 degrees. So I have actually 4 solutions. So I need to look at my coterminal angles for all my solutions. So my solutions. that is negative 150 degrees, negative 210 degrees, 150 degrees, and 210 degrees. Okay, next page. All right, solving the second degree trig equations. Solve for theta in each equation. Give solutions as exact values where possible. Otherwise, give the approximate measures to the nearest thousandth of a degree. More instructions. Similar, but a couple different wrinkles here. Treat sine of theta as a variable and move all terms to one side. Note, sine squared of theta, this is just a notation thing. It's the same as in brackets, sine of theta, entire thing squared. Factor the equation. Now that we have a second degree equation, right, we'll have an exponent of 2. We might need to factor. Use the cast rule. Okay, so remember cast, C-A-S-T. Determine reference angles for each ratio using the unit circle. Check your mode, degree or radians, and then determine all angles which satisfy the specified domain. Check for coterminal angles. Okay, letter A. 2 sine squared of theta plus 5 sine of theta equals 3 for the domain of theta greater than or equal to negative 180 degrees and less than or equal to 180 degrees. So let me rearrange this as 2 sine squared of theta plus 5 sine of theta minus 3 equals 0. I can factor this just like a quadratic, so I have 2 sine of theta. Sine of theta. I'm going to do this by inspection. I know, let's see, so I know it has to be a 3 and a 1. So if I do positive 3 and minus 1, I'll get 6 sine of theta minus sine of theta. That's 5 sine of theta, so that's good. All right, I have two sides of this equation to solve, or two factors. 2 sine of theta minus 1 equals 0, and sine of theta equals negative 3. Let's solve just like we normally do. So 2 sine of theta equals positive 1. And let's calculate our reference angle as, that's sine of theta equals 1/2. And let's calculate our reference angle as the inverse sine of the absolute value of 1/2. And my reference angle is 30 degrees. Sine of theta is positive in quadrants 1 and quadrant 2. So I need to do solutions in quadrant 1 and 2. So let's try to do this without drawing a Cartesian coordinate system. So I know in quadrant 1 that the angle in standard position equals the reference angle equals 30 degrees. So that's one of my solutions. I know in quadrant 2 the angle in standard position equals 180 degrees minus my reference angle, and that equals 180 degrees minus 30 degrees equals 150 degrees. So there are two solutions from this one factor. All right, sine of theta, second part. Sine of theta plus 3 equals 0. Let me isolate sine of theta. All right, let's think about this. Can sine of theta ever be a negative value? It can, but can it be a value? Let's reason this out. Can it be a value where when you take the absolute value of the sine ratio, can it be greater than 1? Here's the problem I have. So sine of theta, that is opposite over hypotenuse, or in terms of the unit circle, that's y over r. Question mark, can it equal negative 3 over 1? Think about a value of negative 3 for y implies that the opposite side is larger than the hypotenuse, this is impossible for a right triangle. So if I have a right triangle and this is y value is -3, so let's say this is in quadrant 4, right? So y value is -3. How can I have a hypotenuse of 1? How? When my y value is -3. So this whole thing will give you no solution. Okay, so no solution is possible here. So my solution is theta equals 30 degrees and 150 degrees. Okay, letter B, last one in this section. Cotangent of theta, tangent squared of theta minus 0.25. Cotangent of theta equals 0, where theta is an element of 0 to 2 pi not inclusive. Okay, so that's, for this one, I'm going to factor out a cotangent of theta. That's tangent squared of theta minus 0.25 equals 0. Let's isolate each factor. Cotangent of theta equals 0. And tangent squared of theta minus 0.25 equals 0. Let's solve for cotangent of theta equals 0. So that I will think of in terms of cosine of theta over sine of theta equals 0. So I need to think of okay, when will cosine of theta equal 0? Well, reference angle equals inverse cosine. Inverse cosine is 0. Well, the reference angle here is pi over 2. Okay, and then cotangent. I'm thinking of the tangent ratio, so I can think of the cotangent ratio is positive in quadrant 1 and quadrant 3. So in quadrant 1, theta equals, well, in quadrant 1, if the reference angle is pi over 2, then the angle in standard position is also pi over 2. Yep. Quadrant 3, theta equals, well, that's pi radians plus the reference angle. So theta equals pi plus pi over 2, and that equals 3 pi over 2. Okay, so I have two solutions from the cotangent angle. Let's do the tangent angle. So here, I'm going to factor by completing, difference of squares. Tangent of theta plus 0.5 times tangent of theta minus 0.5, and that equals 0. So let's isolate each side. So tangent of theta plus 0.5 equals 0, and tangent of theta minus 0.5 equals 0. That's tangent of theta equals negative 0.5. reference angle, that's reference angle equals the inverse tangent of the absolute value of negative 0.5. And so my reference angle is, this one I'll use a calculator, and we'll go to the nearest thousandth of degree, tens, hundreds, thousands, so 0.4636. From here, the tangent ratio, it's negative, so it's negative where? In quadrants 2 and quadrant 4. So let's look for our solutions in quadrant 2. Angle in standard position is equal to pi minus my reference angle. So angle in standard position equals pi minus 0.4636. Angle in standard position is 2.6 tenths, hundredths, thousandths, so 2.678. So that's one solution. In quadrant 4, where the tangent angle is also negative, the angle in standard position equals 2 pi minus the reference angle. So theta equals 2 pi minus 0.4636. My angle in standard position in quadrant 4 is 5.280. There's another solution. Let's go to the other factor. So tangent of theta minus 0.5 equals 0. Let's solve for tangent of theta equals 0.5. The reference angle, it's the same as the other one, but I'll do it nonetheless. So absolute value is 0.5. So reference angle equals the inverse tangent of the absolute value of 0.5. And the reference angle I get is 0.4636. Again, where's the tangent ratio positive? Well, that's in quadrant 1 and quadrant 3. Okay, so in quadrant 1, my angle in standard position equals my reference angle, so that equals 0.464. I'm going to round it to the nearest 10,000th, so there's one solution. And then in quadrant 3, my angle in standard position equals pi plus my reference angle, so that equals pi plus 0.4636. My angle in standard position is 3.605. Okay, we got 1, 2, 3, 4, 5, 6 different solutions. So let's see. Solutions. I have pi over 2, 3 pi over 2, 2.678, 5.280, 0.464, and 3.605.